Today we're going to look at section 3.10, arithmetic sequences. A sequence of numbers is just that, a list of numbers in order. Each value in the sequence is called a term. Terms in the list are often referred to by their location in the sequence, as in the nth term. The notation we use with the sequence is a letter, which represents a term in the sequence, and a subscript, which indicates what place the term is in the sequence. Arithmetic sequences have terms that increase by a fixed number or decrease by a fixed number, called the constant difference, denoted by D, provided that value is not zero. This means the next term is always the previous term, plus or minus a specified constant value. Another way to say this is that the difference between any consecutive terms of the sequence is always the same. So let's determine if the following sequence are arithmetic sequences. Explain your reasoning. Well, let's see, what's the difference here? Difference is 2.2. How about here? Yep, 2.2. So yes, D equals 2.2. Okay, what about this one here? Well, that distance is 2, that's 2, but that's 4. No, there is not a constant difference. How about here? The difference here is 6, 6, 6, 6, 6, 6, 6, 6, 6, 6. So yes, D equals 6. If we have an arithmetic sequence with the first term a sub 1 and constant difference D, the ith term of the arithmetic sequence is a sub I equals a sub 1 plus D times I minus 1. So identify A1 and D for the following arithmetic sequence. Use this to determine the 86th term. So A1, first term. So A1 equals 4.5. And what's the difference? That's 3.6. Yep. So D equals 3.6. So A sub 86 is equal to A sub 1, 4.5, plus D, 3.6, times I, which is 86 minus 1. So we have 4.5 plus 3.6 times 85. And we get 3.6 times 85, 306. So I have 4.5 plus 306 equals 310.5. So if we have the ith term of an arithmetic sequence, a sub I, and the jth term of the arithmetic sequence, a sub j, then the constant difference D is a sub j minus a sub I divided by j minus I. And the first term of the sequence is a1 equals a sub I minus D times I minus 1. The sequence is known to be arithmetic. Two of the terms are a sub 14 equals 41 and a sub 38 equals 161. Use this information to find a constant distance and the first term, and then find 151st term. So we start with D equals a sub j, 161, minus a sub I, 41, over j, 38, minus I, 14. So I have 120 over 24, which is 5. So we now know D. Now to find a sub 1, A sub 1 equals A sub I, which is 41, minus D, 5, times I, which is 14, minus 1. So we have 41 minus 5 times 13, 41 minus 65, negative 24. So now that I have A sub 1 and I have D, I need to find A sub 151, which is equal to A sub 1, negative 24, plus D, 5, times 151 minus 1, or 150, negative 24, plus 750, we get 726. And that is how it works. So the sum of the first n terms of a finite arithmetic sequence written S sub n with the first and last term a1 and a sub n respectively is S sub n equals a sub 1 plus a sub n divided by 2, or n times a sub 1 plus a sub n divided by 2. So what is the sum of the first 101 terms of the arithmetic sequence with a1 equals 13 and d2 25? So we need to find a101 to find the last term. So this is a sub 1, which is 13, plus d, which is 2.25, times 101 minus 1. 13 plus 2.25 times 100. 13 plus 225, 238. So n is 101. So the sum of the first 101 terms is equal to 101 times a sub 1, which is 13, plus a sub n, which is 238 divided by 2. And we have 101, why do I times, this is 251 over 2. And it appears that something is not correct, because 251 divided by 2, 125.5 times 101, it gives me a decimal amount which cannot work. So let's look at this again. What is the sum of the first 101 terms of a arithmetic sequence? A1 equals 13. Oh, D is a decimal, so it will work. Always helps to reread the problem. So this becomes 12,675.5. Okay, Christina decides to save money for after graduation. Christina starts by setting aside $10. Each week, Christina increases the amount she saves by $15, or by $5. How much money will Christina save in week 52? Now note this is in week 52, not through week 52. But I think it meant through week 52, because that fits the problem. So we'll change this to through week 52. So she starts out putting $10 aside. So A sub 1 is equal to 10. She's going to increase that by $5 every week. So D equals 5. We're going to do this for 52 weeks. So A sub 52 equals A sub 1, which is 10, plus 5 times 52 minus 1. 10 plus 5 times 51 plus 10 plus 255 plus 265. So that's how much she would have saved in week 52, but how much would she saved overall? So in this case, n is 52 again. So we're looking for the sum of the first 52, which is equal to 52 times 10 plus 265 divided by 2, which equals 52 times 275 divided by 2, 137.5. And then we're going to multiply that times 52, and we get $7,150. So this is what she would have saved in week 52. This is what she would have saved altogether. In a theater, the first row has 24 seats. Each row after that has 2 more seats. How many total seats are there if there are 40 rows of seats in a theater? So we know A sub 1 equals 24. We know D equals 2. And we know N equals 40. We're looking for a sum, so I need to find A sub 40. I need to find the last one, which is A sub 1, 24, plus D times N minus 1. Nope, we know D. Plus 2. Now this is 24 plus 2 times 39. 24 plus 78, which is 102. So now we need to find the sum. S sub n equals n, which is 40 rows, times A sub 1, 24, plus A sub n, or A sub 40, 102 divided by 2. We get 40 times 126 divided by 2, which is 40 times 63, which is a whole lot of seats. 2,520 seats. So that finishes up our arithmetic sequences section.